Hi, hello guys. Today let's discuss about non-linear pharmacokinetics. So non-linear pharmacokinetics of biopharmaceutics and pharmacokinetics. Today in this class we will discuss about it. So non-linear pharmacokinetics. These are nothing but these are dose-dependent pharmacokinetics. Means these are totally dependent on the dose of the drug we are providing. The kinetics of these non-linear pharmacokinetics is totally dependent on the dose of the drug which are giving. The models implies that these pharmacokinetic behavior of the drug is saturable. It is saturated after some time. The process like saturated processes which will happen are absorption, distribution, metabolism, and excretion. These are pharmacokinetic process. Saturation happens in these process in the form of enzymes or any other things. The saturation occurs in these processes like absorption, distribution, metabolism, and excretion. Because of that, it follows non-linear pharmacokinetics. The process which are usually saturated are metabolism and active tubular secretion. The enzymes and the catalyst will be saturated. So that is why the main process which are usually saturated are metabolism and active tubular secretion. So you can see here absorption. The cause are the factors of non-linearity. What are the factors of non-linearity due to absorption is you see saturable gastric or gastrointestinal decomposition. Why this occurs? This occurs mainly when use the drugs like penicillin G, saquinavir. Like that, saturable transport in gut wall. This occurs when we use the drugs like riboflavin, gabapentin, L-dopa, and baclofen. And intestinal metabolism occurs due to drugs like salicylamide and propranolol. Low solubility but high dose of the drugs like chlorothiazide, griseofulvin, danazol. Like this, these are the drugs and these are the factors which will cause non-linearity during absorption pattern. And during distribution pattern, you can see the transport out of the tissues may occur due to MTX drug, and saturable plasma protein binding may occur due to phenylbutazone, lidocaine, or salicylic acid drugs, and cellular uptake may be disturbed due to methicillin drug, and tissue binding occurs due to IMI, and CSF cerebrospinal fluid transport occurs due to benzyl penicillins. And the metabolism, there are different drugs you can see like phenytoin, carbamazepine, propranolol, diazepine, and the factors like enzyme induction, enzyme limitation, metabolite inhibition. And during excretion, the causes are the factors which will cause are active secretion, tubular reabsorption, and change in urine pH. Active secretion is mainly affected by the drugs like meslocillin, para-amino, hippuric acid. And tubular reabsorption is mainly affected by the drugs like riboflavin, ascorbic acid, and cefaclor. And change in the urine pH may occur due to the drugs like salicylic acid and dextroamphetamine. And excretion. The factor excretion is mainly occurs due to the cause of biliary secretion or enterohepatic recycling. Biliary secretion is affected by the drugs like iodipamide, sulfobromophthalin, sodium. Enterohepatic recycling may occur due to the drugs like cimetidine, isotretinoin. And another important equation of this nonlinear pharmacokinetics, the rate equation of nonlinear pharmacokinetics is nothing but the MICHAELIS-MENTEN equation. It is proposed by MICHAELIS-MENTEN, so that is why it is called as MICHAELIS-MENTEN equation. According to this equation, the formula is dC by dt is equal to V max into C by Km plus C. C is nothing but the concentration. dt by dt is what? dC by dt is nothing but rate of decline in the drug concentration along with the time. And Vmax means what? It is the maximum rate of process. And Km is nothing but Km is the Michaelis constant. So this is the formula of Michaelis-Menten equation. With this, we can grab these formulas from that. And also, this is the graph you can see here by taking dose on the x-axis and study concentration on the y-axis. When you plot a graph, then the linear kinetics will follow a linear line and non-linear kinetics will be deviated from the linear line. And you can see another graph when you plot a time after dose on the x-axis and plasma concentration on y-axis, the distribution phase will be reflected like that and the elimination phase and the total line will be like a reverse parabola. And by using this MICHAELIS-MENTEN equation, we will plot different plots like a Lineweaver-Booth plot, or it is also called as Clarge plot. How it will be plotted is by taking the reciprocal of the MICHAELIS-MENTEN equation. That is dr is equal to Vmax into CSS by Km plus CSS. By taking that equation, if you take the reciprocal of this equation, and if you take 1 by CSS on x-axis and 1 by dr on y-axis, then the slope is equal to Km by Vmax. This is Lineweaver-Booth plot. And the next one is direct linear plot. This plot is mainly drawn by taking steady state concentration of drugs 1 and 2 and also dose rates of drugs 1 and 2. By taking these different rates and steady state concentrations, if you plot a graph, then that is called as direct linear plot. And the last plot, that is called as graphical method. By using the equation, by plotting a graph, then we can conclude to a result. That result can be drawn from the graph. That is why it is called as third one, that is called as graphical method. So this is about MICHAELIS-MENTEN equation, and these are some of the graphical methods, and the formulas, everything will be like the previous classes. So this is about non-linear pharmacokinetics simply. Thank you.